Hey everyone, welcome back to the channel. This is Rob. If you're just finding me, I hope that you will stick around and enjoy the content. If you're not already subscribed, if you want to hit the subscribe button, I would greatly appreciate it. It's a bit more difficult than most might realize gaining subscribers when you make this type of content. So, and of course, if you find the video helpful, if you want to give it a like as well, it's more than appreciated. And I'm just going to thank you for that right now because I trust that you've done it. So with that being said, today's video is going to be on Cisco EVN. What does EVN stand for? EVN stands for Easy Virtual Network. So what's so easy about it? Well, anybody familiar with VRFs, or should I say like VRF Lite in specific, when you're just using VRFs to isolate things at layer 3, and you have a situation where you need to trunk some VRFs to a firewall or to another router or something like that, and you have to create all of these different sub-interfaces and stick the sub-interfaces into the correct VRF. And if you have a lot of VRFs, that can become a little bit cumbersome. So that's where the Easy comes into play with Cisco Easy Virtual Network. And I'm going to hop over here on GNS3 and run through a pretty basic scenario and configure the whole thing and show you how it works. Okay, so if we look over here at the topology, we have a few routers on the screen. So we have a red, which will be in our red VRF, blue, which will be in the blue VRF, and then R1 and R2, where we're going to set up our EVN. So the subnets are as follows. We have the 10.0.0.0 network here, 10.1.0.0 right here, 10.2.0.0 right here, and then 10.3.0.0. The only thing I have done so far is I've configured the interfaces on these routers. So red 1, red 2, blue 1, and blue 2. And the default gateway, which will be pointing towards either R2 if it's on this side or R1 on this side. I have not configured anything on R1 or R2 because that is where the main configuration is going to take place. And once I create the VRFs, even if I would have configured the IP addressing on the interfaces, that would have been removed anyways. So the goal here in this lab is to have communication between red 1 and red 2 and blue 1 and blue 2 using Cisco Easy Virtual Network. So we're going to pop open R1, and I kind of want to have the whole topology in here as well as the terminal window. So maybe if I move this over a little bit. Okay, perfect. Alright, so we're currently sitting on R1. And I'm going to start by configuring the... I guess I'm going to start by configuring the VRFs. That would make the most sense because, like I just said, once you apply a VRF to an interface, it will remove the IP addressing. So, go into privilege exec mode, then global config. And I will start by saying VRF definition red, address family IPv4, and then VNet tag. And for the red VRF, I will give it a virtual network tag of 10. And that's it. So we'll do the same thing for the blue VRF. So VRF definition blue, address family IPv4, VNet tag 20. Alright, so now that I've done that, I can go ahead and I can stick these interfaces in the appropriate VRFs. So we will go into gig 0/1, and stick it in the red VRF, and then gig 0/2, stick it in the blue VRF, and then we will continue on with our IP addressing. So go over here to interface gig 0/1, VRF forwarding red, and we are going to give this interface an IP address of 10.0.0. No, it's funny, I thought I was seeing too many zeros there for a second. I was like, wait a minute. So so this is the .2 right here. So over here on R1, we'll give it an IP address of 10.0.0.1. So IP address 10.0.0.1/24 mask. Do a no shutdown. And pretty much the same thing over on gig 0/2, except it will be in the blue VRF. So we'll say VRF forwarding blue, IP address. I'm struggling to type today for some reason. So we'll say IP address, this is in the 10.1.0.0/24 network. This is the .2 over on the blue 1 router, so we will give this the .1 address. So we'll say IP address 10.1.0. Or did I say .1? I'm not sure what I said, but either way, the IP address is going to be 10.1.0.2. I'm sorry, no, I was correct the first time, 0.1. This is the .2. And can't forget the subnet mask. And perform a no shutdown. Say do show run interface gig 0/1, which is this one. So we're in the red VRF, we have an IP address, and it is not shut down. Blue VRF IP address, it's not shut down. Do show IP interface brief. We have gig 1 and 2, both are up and up. So really quick, let me just make sure that I can ping from R1 the red one and the blue 1 routers from their corresponding VRF. So I'll say do ping VRF red 10.0.0.2. Sits in an ARP, and then perfect. And the same thing with the blue VRF. So do ping VRF blue 10.1.0.2. Okay, so we have reachability from R1, and I'll move on to configure this link right here. So this 172.16.1.0/30 network is going to be our virtual network trunk. So this is going to be the link that will be shared between all of the VRF. So between the red VRF and the blue VRF, this link will be shared between those. So this configuration is going to, and this is why it's called Easy Virtual Network, is because it's going to do the sub interfaces for us, and I'll show you that at the end. Except we just have to enter a very simple configuration on these interfaces to get this to work. So I'm going to go ahead and show you that right now. Actually, I feel like besides adding the VNet tag to the in VRF configuration mode, I feel like this is kind of the meat of the lab right here. So you know what? I'm going to hold off on this link right here, since this will be our trunk link for the VRFs, and I'm going to configure R2 really quick, and then I will come back to this. So let's pop open R2. And at this point, I'm sure you're seeing what's going on, so I'm just going to go ahead and just kind of speed through the configuration here. It's going to be the same thing as on R1, except we just have different subnets over here. So the 10.2 and 10.3 network. Okay, so let's go ahead and configure. So we'll start over here back with R1. Let's go ahead and configure this link right here. So we will say interface gig 00, and IP address will be 172.16.1.1, 255.255.255.252. Make it a /30. Do a no shutdown. And we will use the vnet trunk command. So this is where the magic happens. As soon as I enter this command, it is now a virtual network trunk. And that's pretty much it. So let me go ahead and jump over to R2 and do the same thing. So we'll go to gig 00, IP address 172.16.1.2, no shutdown, and let's send a test ping 1.1. And if you've noticed, I didn't put this in any VRF. I simply am issuing the vnet trunk command, and that's it. So this automatically gives us the configuration that we would have if we were using sub-interfaces. So the traditional way to do this would be, we would go, let's say, interface gig 0/0.10. And we would configure 802.1q encapsulation, give it an IP address, or stick it in, we'll say the red VRF, give it an IP address, and move on to, say, gig 0/0.20, issue the encapsulation .1q command, put it in the blue VRF, give it an IP address. So this vnet trunk, and then assigning these VRFs the vnet tag, makes it easy. Hence the easy virtual network. So if we issue the, go back to privilege exec mode and say show derived config pipe begin gigabit Ethernet 0/0. Oh, interesting. Do you see what happens? So us issuing the vnet trunk command on this gig 00, it automatically filled this in for us. It automatically gave us our sub interfaces. So you see interface gigabit Ethernet 0/0.10, put a description in there for us. So we see sub interface for vnet red, encapsulation .1q10, that's the tag for the red VRF, and the IP address. Same thing with the gigabit Ethernet 0/0.20, sub interface for virtual network blue. That is what this is all about. You are greatly reducing the burden, the configuration burden, by using the going the easy virtual network route. No pun intended. Then going in and configuring the stuff, or these things one by one. And as you can see, if we had more than just two VRFs, how cumbersome the configuration might become. So anyways, let's move on, and let me get out of this, and let's prove that it works. So in order to do that, we have to have reachability between these subnets, because even if we hop over here to, let's pop open red 1, and let's try to ping red 2. So we'll say ping 10.2.0.2. We're not going to get a response. Matter of fact, we're going to receive an ICMP unreachable message from R1, because R1 doesn't know how to get there. So if we pop open R1 and say do show IP route, VRF red, all we have are the directly connected routes. So we have the 10.0.0.0 network, and we have this point-to-point link right here. So we need to fire up OSPF and throw these interfaces into OSPF for their corresponding VRFs. So we'll say OSPF, or I'm sorry, router OSPF 10 VRF red. Say router ID 1.1.1.10. And network, I'm going to add this interface right here. So we'll say network 10.0.0.1 area 0, and then network 172.16.1.1 area 0, which is this interface right here. Okay, and then we'll move on to the OSPF process for the blue VRF. So router OSPF, we'll say 20 VRF blue. We'll give it a router ID of 1.1.1.20, and we're going to throw gig 0/2 in there. So we'll say 10.1.0.1 area 0. Now I'm a big fan of just throwing the interfaces in OSPF under the interface itself. But with this, since I don't think there's any other way to do it except issue the network command, that's why I'm issuing the network command within OSPF for these links as well. Otherwise, I would just go under the interface and say IP OSPF, area 0 or whatever. All right, so network 172.16.1.1. And also, for anybody that might be curious, the reason I am adding the specific IP address instead of the network is because it's actually best practice to be very specific when adding interfaces into OSPF. So I very specifically define the 172.16.1.1 as it is on the gig 0/0 interface. Same thing with this network, and the same thing with this one right here. And then even better practice, which I'm not doing since it's a lab, is to use the passive interface default command, and actually, which, you know what? Honestly, I mean, if I'm going to do this, I might as well do it right as if it was in a production environment. So we'll go back to router OSPF 10, passive interface default. So what that's going to do is not send hellos out of any interface. So no OSPF adjacencies will actually be formed, but we want an adjacency to form between R1 and R2. So this is for, and I don't want to go down the a rabbit trail of this isn't an OSPF video, but say you have at your network edge where there are no adjacencies to be formed, you don't want to. So say you are you have a switched access layer up to your core switches, and you don't want the core switches to form an adjacency with each other through the access switch, as well as you don't want anybody to form an adjacency, an OSPF adjacency, by connecting something to that switch that's also running OSPF, since OSPF would be actively sending hello messages unless it was a passive interface. So by saying that these are passive interfaces, the interfaces are added into OSPF. These networks will be part of OSPF. They will not send hellos. So you can either do passive interface default and then one at a time, which is what I'm going to do, say no passive interface, which is best practice, or you can do it the opposite way and specifically set your passive interfaces. So as you see, I've used the passive interface default command, so that means I need to say no passive interface gig 0/0. Let's see, I may have made a mistake. Do shell run pipe section router OSPF. Let's see, router OSPF. That's odd. I'm not sure. I'm not sure why. That is part of that OSPF process. Router OSPF 10 VRF red. I assume I'm going to get the same error on this as well. So let's try no passive interface gig 0/0. You know what? I'm not sure why that's happening, to be honest with you. So I'm sure it has something to do with the VNet trunk. So I'm not going to really waste any time messing around with it. So I'll just say passive interface. I'll do it the opposite way that I was mentioning. So we'll say for the red VRF, passive interface gig 0/1, and then router OSPF 20, no passive interface default, and then passive interface gig 0/2. Do show run pipe section router OSPF. We have the red OSPF process. All right, passive interface gig 0/1, so we're not going to be sending hellos out there because we don't have to. Blue VRF, passive interface gig 0/2. We have our networks in there, and we should be good. So let's jump over to R2 and essentially configure the same thing. So we'll say router OSPF 10 VRF red, router ID 2.2.2.10, network 10.2.0.1, passive interface gig 0/1. Let's add our VNet trunk. So we'll say 172.16.1.2. And as soon as we do that, we should see an OSPF adjacency form. There we go. And router OSPF 20 VRF blue. Router ID 2.2.2.20. Network 10.3.0.1. Area 0. Passive interface gig 0/2. And network 172.16.1.2. Area 0. And we should see our final OSPF adjacency come up. And if I wanted to get really technical, I actually should have added the OSPF network point-to-point command here, but that's what it is because there doesn't need to be a DR or BDR election on a point-to-point link. But for the lab, it will work just fine. So now that we have our OSPF adjacencies up, let's issue the show IP route VRF red command, and we should see, and we do, an OSPF route for the red 1 network over there on R1. Via gigabit Ethernet 0/0.10, that subinterface that was automatically created for us by issuing the VNet trunk command on gig 00 over here. So if you followed along this far, I really appreciate it. This is the end of the lab. Everything is configured. So the final thing here is essentially just testing to make sure we have reachability. So we'll start over here at router red 1, and we will attempt to ping red 2. So we'll say ping 10.2.0.2 and 100%. And let's try the same thing on the blue VRF. ping 10.3.0.2, 100%. So there you go. And then of course, obviously we're not able to ping, so if we were to try to ping red 2 or red 1, we'll say red 1 from blue 1, so we'll say ping 10.0.0.2. Obviously we're not going to have reachability because these are isolated at layer 3. But we do have reachability across R1 and R2 using that VNet trunk, and we are able to reach the router at the other side in the corresponding VRF. So that is it. I really hope that you enjoyed this video. I hope that you learned something. If you have any questions, please don't hesitate to reach out. You can reach me via email at rob@rmtechcentral.com. You could use the contact form at rmtechcentral.com, or you can leave a comment in the comment section below. If you're not subscribed to my channel, I would really appreciate it if you would hit the subscribe button. It's actually very difficult to get subscribers, more difficult than most might think when you make this kind of content. So subscribing is probably one of the best ways that you can say thanks, and I very much appreciate it. And then of course, if you found the video helpful, please give it a like as well. That's it, and thanks for watching. I'll see you in the next video.